All right, let's talk about some chemistry tonight. We have energy and matter as two items. Matter is everything that occupies space and has weight. Everything, everything that's stuff in our world is matter. Like your table, your pen, yourself, your matter, a lot of it. Matter generally comes in three states. We have a solid state, a liquid state, and the gaseous state. We can look at that really simple with water. When we look at water, the solid state is our ice. The water is different when it is solid as ice than when it is liquid, which is when we have water. On the temperature graph on this picture, we can see 0 degrees is when water turns into ice, and then it is water, liquid, until it turns 100 degrees Celsius, and then it turns into steam, and steam is a gaseous form of water. That is actually how they determined the scale for Celsius. 0 is the melting point, and 100 is the point when water turns into gas, steam. Energy is the other concept. Energy has no mass, nor does it have weight. We cannot touch that. We don't really know about it, except we know about it because we have an effect on matter. So we can be measured by what it does to the matter. For example, we have this little card here with a balloon, and we blow that balloon up, and then we put the card on the floor and we let the air out, and the air pushing out will move that balloon. We can see the card moving, but the energy that is produced to move that balloon, we can't see that energy. So energy is the ability to do work or put matter into motion. We have two main types or two states that the energy is in. One is a kinetic state, and that's when energy is actually performing work. That means you're running, your muscles perform work, or that means that air-filled balloon the air goes out and the car moves forward. Potential energy is inactive energy. It's more like stored energy in our body. That's fat in a device that can be a battery that then lets the energy go out, so we can do kinetic energy. In this example with the balloon, the potential energy is when the balloon is filled with air and is just closed and cannot escape. That's potential energy. Energy is different types of energy that are in our body. On top here you see a graph, forms of energy. Different forms: mechanical, electrical, thermal, radiant, chemical, sound, or even nuclear. Energy is a flowing thing. So let's talk about chemical energy first. Chemical energy is energy that's stored in a substance molecule's bond. You see here where it says metabolism, it says catabolism. That is, catabolism is when we break a bond in a chemical, we release some energy. And that energy in the body is measured as adenosine triphosphate, or ATP, but that's the body's energy. So chemically speaking, bonds can hold energy. Electrical energy is when particles move around in the body, or in wires, in forms of electrons, or for us in the body, they're ions. So we got a little electricity showing there, that it shows that the electrons or the ions are flowing around. And then mechanical energy, that's just moving things. So I got an eyeball here, and we contract the lower muscle, and guess what? The eyeball moves down. So it looks down. That's mechanically moving something. And then radiant energy is light energy, such as visible light, the sunlight. That's energy. That's a type of energy. We can actually harvest electricity with solar panels. That's the reason why we can do that. And then also we have X-rays. Those are also radiant energies. When we convert energy, we can do that quite easily, but we lose heat. And heat is a waste product at that point. atoms. Atoms are incapable of dividing structures. They are actually able to, we are able to break them further down, but that was what the word means. That's what the word means. So we try to figure out what are the basic structures that make up the body, and that's what we're looking at when we look at atoms. It's a limited number of substances on the periodic table of all the elements, and an atom is one of those elements as a particle, one particle, and the element is just a bunch of the same ones. When we look at the structure, we have a center that's like our sun, so to speak, and then we have things flying around the center, orbits and energy. So the nucleus is the center. The nucleus is made of a proton, a positively charged, a little small particle, and a neutron, which is a particle of similar size, but it has no charge. And then around the nucleus, in orbits, we have electrons, which are negatively charged particles, fly around there. And the electrons are much, much smaller in size, but from an energy perspective, they have the same energy as the proton does. So when we have atoms that combine chemically, we make molecules. A chemical reaction, we make molecules out of that. These are a few molecules that we can see here on the screen. And chemical reactions are reactions that happen when molecules or atoms combine or dissociate from one another. And then we see what we do with that. We harvest that energy or we put energy in to make it. Atoms combine, forming chemical bonds with other atoms. So chemical bonds is going to be a topic coming up pretty soon here. So, but let's look at these bonds a little bit more before we chemically react, because when we actually look at the bonds, the interactions that make up bonds are the electrons interacting with each other. And it's most likely, most of the time, the electrons on the outermost orbit. We call that valence. So the valence electrons are the ones that interact with other atoms. So the valence electrons of one atom interact with the valence electrons of other atoms. So the valence electrons are therefore the ones that determine the behavior of an atom. That brings us to the octet rule. That's the rule of 8, which means that most of the atoms, they have a valence, an outer shell, that carries a maximum of 8 electrons and is reactive if it contains less than 8. So if it has 8 electrons in that place, we call that an inert element because it's non-reactive. But if it is not having 8, if it's got less than 8, we got reactivity going on. And that brings us to chemical bonds. We have two main types. We have a bond where the electrons either transfer or they transfer from one atom to the other. It's called an ionic bond. Then we have bonds that are sharing electrons, and those are called covalent bonds. Depends how many electrons we share. We can call them single, double, or even triple bonds. In terms of the covalent bonds, then we have two more things. We have non-polar covalent molecules, and those share the electrons equally. A good example of that is carbon dioxide. It's carbon with 2 oxygens on either side, a straight line. Or the one that we see here as methane, or ethane, that's also, you see how balanced that molecule looks in terms of the spacing between the white dots are pretty symmetrical. And then we got polar covalent bonds that share the electrons unequally, and those are polar, not non-polar. And water is a good example. That's the molecule there with the red dot and the 2 whites on the side. But look, on top, there is not another white, so the spacing is not equal. And so we have areas of positive energy and areas of negative energy with that. And so we can use that in the water and create what we call hydrogen bonds. So we can use those positive centers and negative centers and then interact within water molecules. So the positive and the negative pole of a polar covalent molecules are attracted to each other, forming a weak connection. This then forms bonds within larger molecules. So they're weaker than covalent or ionic bonds, but they hold larger structures together in specific ways, such as protein or the DNA helix, as we can see here. And that then is very instrumental in the large molecule that it can work that way.